Section 5.3, Trigonometry Functions of Any Angle. I have some angles drawn here, and these angles are in standard position. We're going to talk about these angles. This first angle you see is in the first quadrant. Let's read about it. The point P, which is XY, is a point r units from the origin on the terminal side. Okay? So here we have point P. It is r units from the origin on the terminal side of theta. Okay, here's angle theta. A right triangle is formed by drawing a line segment from P, which is XY, perpendicular to the x-axis. Okay, so you see a triangle was drawn. We drew a straight line 90 degrees down, forming a triangle. Perpendicular. This line is drawn perpendicular to the x-axis. Note that y is the length of the side opposite theta, and x is the length of the side adjacent to theta. So here we have y is the side opposite theta, and x is the side adjacent to theta. This is in quadrant 1. You see we have the same situation with the triangle and theta lying in quadrant 2. We have the same situation in quadrant 3. Theta lies in quadrant 3. We have the same situation on the last one where theta lies in quadrant 4. Okay? So, next, I want us to talk about the definition of trigonometric functions of angles. Let theta be an angle in standard position, and PXY be a point on the terminal side of theta. Well, that's the same diagram that we were just looking at earlier. Okay? Here we have point P. We have the distance between the origin and point P is r. Now, notice this statement. It says if r equals to the square root of x squared plus y squared is the distance from the origin to xy. Now, let me tell you where they got that from. All right, we know the Pythagorean theorem is x squared or a squared plus b squared equals c squared. But we will use x squared plus y squared equals r squared for our Pythagorean theorem to represent this triangle. The two legs, x squared plus y squared, equals the hypotenuse, which is r squared. To find r, we take the square root of both sides. So you end up with r is equal to the square root of x squared plus y squared. So that's where this statement comes from. If r equals to the square root of x squared plus y squared is the distance from the origin to xy, as shown in this figure here. With that being said, the 6 trigonometric functions of theta are defined by the following ratios. Sine is y over r. Cosine is x over r. Tangent is y over x. It's still Oscar had a heap of apples. It's just we're looking at it as x's, y's, and r. The x-axis, the y-axis, and then r. Then you would find the cosecant, secant, and cotangent by the reciprocal. The reciprocal of y over r is r over y. Secant is r over x, coming from the reciprocal of cosine. Cotangent is x over y, coming from the reciprocal of tangent. Now, notice we've got here x cannot be 0. If you have 0 in the bottom on any fraction, it is undefined. So y cannot equal to 0 on cosecant, x cannot equal to 0 on secant, and y cannot equal to 0 on cotangent. You can have 0 on top. If you have 0 on top, 0 divided by any number is 0. But if you have a number divided by 0, you get undefined. So we need to remember those rules as well. Now, Next, I want us to look at an example using these 6 trig functions that we've talked about and using the x, y, and r values. So, an example of evaluating trigonometric functions. Let P equal to -3, -5 be a point on the terminal side of theta. Find each of the 6 trigonometric functions of theta. So, I have drawn the point -3, -5. Here's the point -3, -5. Now, I'm going to draw the y. We already have the x is -3. This is x. My y is -5, and I'm going to circle these values. And then we have our r. So here we have our right angle, and we have our right triangle. Now, we need to find r. You can run it through the complete Pythagorean theorem, or you can just recall that r is the square root of x squared plus y squared. We just talked about that. So r is equal to the square root of x is -3 squared plus y is -5. I always put my numbers inside parentheses when I'm going to raise to a power. So -3 squared is 9, -5 squared is 25. If you add those together, you get the square root of 34. So when I look at that problem, I see that my radius is the square root of 34, or my r. That is my r. Okay? So, let's remember our little rules from our previous figure here. All right, we're trying to find sine. Sine is always, think of here's theta, okay? You've got theta coming all the way around, okay? So, sine is y over r, opposite over hypotenuse, so that's -5 over the square root of 34. Now, we will need to rationalize that. You never leave me a radical in the denominator. So let's multiply numerator and denominator by the square root of 34. So I end up with -5 times the square root of 34 over, well, square root of 34 times square root of 34 gives you 34. When you multiply two square root radicals that are identical, your answer is what's inside. So we end up with sine of theta being -5 square root of 34 over 34. Now, cosine. Remember cosine. Adjacent over the hypotenuse. X over r. So x would be -3 over the hypotenuse, which is r, is square root of 34. So I need to rationalize that denominator by multiplying numerator and denominator by the square root of 34. I end up with -3 square root of 34 over 34. So that would be your cosine. And then tangent. Tangent is y over x. So your y is -5 over your x is -3. A negative divided by a negative, you always change that to a positive. So tangent is 5/3. Cosecant. Remember, cosecant and sine are reciprocals of one another, although we know that cosecant is r over y. Cosecant is r over y. So let's just take the reciprocal here. That would be square root of 34 over -5. That would be my answer there. I could put the negative out front and make that negative square root of 34 over 5. Secant is the reciprocal of cosine, so that's square root of 34 over -3. Or again, put that the negative out front, so that would be negative square root of 34 over 3. And the cotangent is the reciprocal of tangent. So the reciprocal would be -3 divided by -5, which is positive 3/5. So here we have found all 6 trig functions. So again, cosecant was the reciprocal of sine, gave me negative square root of 34 over 5. You can leave me a radical in the numerator, you just can't leave me a radical in the denominator. You have to rationalize like we did on sine and cosine. Secant was negative square root of 34 over 3, and cotangent was the reciprocal of tangent, which was 3/5.